this lesson is on working with formulas. What is a formula anyway? It's an equation that relates two or more variables. But how do we solve a formula? Solving a formula means to rewrite it in an equivalent form so that the variable that you're interested in is isolated on one side of the equation. An example of that is good old E equals mc squared. Here's a list of some common formulas that are used in this unit. Take a moment, pause the video, jot them down if you like. Let's move on to some examples of solving formulas. The first example, number 1, relates Celsius and Fahrenheit. Now, let's just think of how we would operate on Fahrenheit to find Celsius. Well, using the order of operations, you would notice that first you would take your Fahrenheit, then you would subtract 32, then you would multiply by 5, and then you would divide by 9. Now, if you take these operations and work backwards, because that would give you your Celsius, you work backwards from your Celsius, you'd have to oppose all of those things. So you'd actually have to multiply by 9 first, then divide it by 5, and then add 32, and you'd get back to your Fahrenheit. So let's do that. So to get Fahrenheit by itself, we need to simplify this a little bit, get rid of some of the items. In this case, the 9. So let's multiply both sides by 9. We're allowed to do that. That gives us 9 times the Celsius amount is equal to, 9's cancel, 5 times the Fahrenheit minus 32. Now we can divide both sides by 5, giving us Fahrenheit minus 32 equaling 9/5 times the Celsius. 9c over 5 is the same as 9/5 c. And then to oppose that subtraction of 32, we would add 32, giving us Fahrenheit to be 9/5 the Celsius plus 32. The formula is now solved for F. Question 2 has ax plus by equals c, and they want you to solve it for y. So I like to somehow bold the letter that I'm interested in and pretend the rest of the other letters are just, you pretend they're numbers. So if the rest of them were numbers, so say it was 2 times 3 plus 5y equals 9, right? You'd want to get rid of this guy first. So you want to subtract the ax term for both sides, leaving you with by equals c minus ax. Now, all that's left to do to get y by itself is remove the b, and the b is attached to the multiplication. So we oppose that, and we divide both sides by b, canceling that out, and we got y by itself. Now, the tricky part here is there are many ways of writing your final answer. So you'll notice in number 2 here, you could leave it like this. You could also rewrite it as c over b minus a over bx. Or you could say c over b minus ax over b. So those are 3 different ways of writing the exact same expression. Now that I think of it, Fahrenheit could have also been written with a common denominator. So you could have taken that 9c over 5 plus 32 and rewritten as times 5 times 5 with a common denominator. 32 times 5 gives us 160. So that'd be 9c plus 160 over 5 is another way to write the expression for Fahrenheit. As a note, I will accept either of those ways as long as your variable is on its own and this portion is as simplified as you can make it, and it's fine either way. Let's check out this volume formula. So we want r squared to be all on its own. So there's a few things bothering it. There's a 1/3 times a pi times the r squared times the h. We want the r squared on its own. Let's first get rid of the fraction. So multiplying by a third, to oppose that, you can multiply by 3, or 3/1, the reciprocal. Taking 3/3 is actually just 1, but we did that to this side, so we have to do that to the other. So we've got 3v equals pi r squared h. We still want r squared to be alone, so let's get rid of the multiplication by pi and the multiplication by h. We can do that in one step by dividing by pi h on both sides. So the pi's cancel, the h's cancel because it's multiplication, so r squared is equal to 3v over pi h. Next up, we've got another formula here. They want this one solved for s. So we need to isolate s by itself. Let's first get rid of the fraction bit here. So let's multiply both sides by n. And you've got dn equals c minus s. The n's cancelled. You'll notice that often the order in which letters are written in one term follows the alphabet. Okay, you want s by itself. So now you've got a few options. If you want to keep it on the right-hand side, then you can subtract c from both sides, giving you dn minus c equals negative s. But you're still not done yet. You don't have s by itself yet. So to oppose a negative, we could multiply everything by a -1, therefore changing all of the signs, and that's fine. And you could also rewrite it or as c minus dn, which is a little bit neater looking. Here is yet another example of using formulas. Let's take a look at this word problem. A parade float travels down a 5.5-mile long parade route at 2.5 miles per hour. They're asking us how long it will take the float to complete the parade route. So let's analyze the problem a little bit. They're giving us a distance and a rate, and they're asking us for the time. If you think back to the formulas that we looked at earlier in this lesson, you'll notice that there is a very common formula that tells us that a rate times a time gives us a distance. So now since we want time, let's get time by itself. Let's solve this formula for t. To get rid of the timesing by r, we can divide by r, giving us time is equal to distance divided by rate. Side note here, here's a cool little triangle you can use to remember this. You've got distance equals rate times time, and time is equal to distance over rate, and rate is equal to distance over time. Alright, let's take a look and use this formula. Input our amounts. So we've got time is equal to distance over rate, which gives us distance 5.5, rate 2.5. 5.5 divided by 2.5 gives us 2.2 hours.